When you stand on the sidewalk and look up at a massive, I don't know, 100-story skyscraper, there's this really profound illusion of permanence.
Oh, absolutely. Like it's always been there.
Right. It looks like it was just dropped there by some giant hand, fully formed and perfect. But what you don't see are the the months of digging the foundation or the endless blueprint
The
revisions.
scaffolding.
Exactly, the scaffolding, the meticulous pouring of concrete, and really just the sheer orchestrated chaos that had to be perfectly managed to get that tower into the sky.
Yeah, it is so easy to only ever see the finished product. I mean, we look at a functioning cloud infrastructure and just assume it works. We completely miss the sequence of highly structured events that kept the whole thing from just tipping over during construction.
And that actually brings us to today's deep dive. We are looking at a huge stack of notes, official HashiCorp documentation, and study guides for the Terraform Associate 003
A
exam.
lot of material.
Oh, so much material. But our mission today, we are going to completely master the core Terraform workflow. Because whether you are studying to ace the certification or you're just, I don't know, trying to survive your first week as a junior cloud engineer without accidentally deleting your company's entire database.
We've all been there.
Right. You have to internalize this sequence. It is the absolute lifeblood of infrastructure as code. And we're going to use that exact construction project lifecycle to guide us today. Building cloud infrastructure is exactly like building that skyscraper.
What's fascinating here is that the cloud itself is pure chaos.
Yeah.
I mean, it's ephemeral. It changes constantly. Cloud providers update their APIs like every single day.
Yeah.
But this core 5 command sequence, it is the unbreakable foundation. It doesn't matter if you are deploying a simple web server or this massive multi-region enterprise-grade network.
Yeah.
The laws of physics for Terraform do not change.
Okay, let's unpack this because you literally cannot build a skyscraper without prepping the construction site first, right?
Right.
You have to secure the perimeter, bring in the heavy machinery, set up that little temporary trailer for the site manager. So in our world, that is phase one, breaking ground. And looking at the study guides, the command for that is Terraform Init.
Yes.
But I want to pause before we just memorize a command. What is actually mechanically happening on my laptop when I pipe that in and hit enter?
Well, that is exactly the right question to ask because Terraform doesn't just inherently know how to talk to every single cloud provider on Earth.
Oh, really?
Yeah.
Yeah.
When you write your code and declare, I want to build a server in AWS, Terraform needs the specific instruction manual and the API translation tools for AWS.
Okay.
So mechanically, it reaches out to the internet, finds the exact AWS plugin required, and downloads it into a hidden folder on your hard drive. It's called the .terraform directory.
Ah, okay. So that folder is basically your temporary site manager's trailer.
Exactly. It's bringing the heavy machinery for this specific job.
Got it. I also see in the notes here that it initializes the backend. What does that actually mean in this context?
So the backend is where your state file is stored. We'll get much deeper into the state file later, but for now, just think of it as the master ledger of truth.
Like a record book.
Right. It's how Terraform remembers what it has already built. So Terraform Init establishes the secure connection to wherever that ledger is stored. That could be locally on your machine or remotely in like a cloud storage bucket.
Okay, I want to put you in the hot seat with a scenario here.
Let's hear it.
Imagine you are on the job. You've been deploying AWS resources all week. Suddenly, you realize you need to add a DNS record using Cloudflare. So you add the Cloudflare provider to your code, you confidently run your next command to see what will happen, an immediate error. The code is perfectly written, but it completely fails. Why?
Because the site manager doesn't have the Cloudflare tools yet. This is a classic exam trap. People think, and it's just a one-and-done first day of the project command.
But it's not.
It is absolutely not. Anytime you add a new provider to your configuration or, and anytime you change where your backend ledger is stored, Terraform needs to download new machinery or reconfigure its connection.
Okay, so if you don't run Init...
Terraform looks at your Cloudflare code and just gives up because it has literally no idea how to communicate with them.
Wow. You have to bring the right tools to the site.
Yeah.
If you add a new vendor, you have to authorize them at the gate.
Exactly.
All right, so the site is prepped. We've got our heavy machinery. Phase 2 is drafting and checking the blueprints. Before we show our architectural plans to the lead engineer, we need to make sure they're actually readable.
Yes, very important.
And this brings up Terraform FMT. But I have to push back here on behalf of anyone who has ever argued about coding styles. isn't formatting just an aesthetic preference? I mean, we're talking about spacing and indentation here. Why would an official, highly technical certification exam care if I use spaces versus tabs?
Well, in a vacuum, a computer certainly doesn't care about your spaces. But Terraform is rarely used by just one person in a vacuum. It is an enterprise collaboration tool.
Right.
If we connect this to the bigger picture, imagine a team of 50 engineers all writing code and committing it to the same repository. If everyone has a different formatting style, some use tabs, some use spaces, some align their equal signs, some don't, what happens when you review a pull request?
I guess you'd just see a massive wall of red and green text for every single minor change.
Exactly the problem.
Yeah.
You are going to see hundreds of lines of changes that are purely spacing adjustments. It creates massive visual noise.
Oh, I hate that.
Right. And that noise hides the actual dangerous infrastructure changes inside a blizzard of formatting tweaks. By running Terraform FMT, it automatically rewrites your configuration files to a canonical standard format.
Oh, that makes total sense. It masks the real work if you don't do it. If everyone's code looks exactly the same, code reviews are entirely focused on what is actually being built rather than arguing over how many times someone hit the spacebar.
Precisely.
And there's a specific flag the exam highlights here, right? Is it re-recursive?
Yes, re-recursive, and it's a huge time saver. By default, FMT only formats the files in the specific folder you are currently looking at.
Okay.
But enterprise projects have dozens of subdirectories and modules. You don't want to run that command 50 times. Adding the recursive flag tells Terraform to basically tunnel through every single folder in your entire project and format everything in one shot.
Good to know. But, formatting doesn't mean the code actually works. A blueprint can look beautiful and still be fundamentally flawed.
Very true.
Which brings us to Terraform Validate. Now, I want to get this crystal clear because the notes heavily imply this is a major exam trick. If Validate says my code is good, does that mean it's going to successfully build in the cloud?
No, it absolutely does not. And that is the exact trap. You have to understand the strict boundary of what Validate actually does.
Okay, what does it do?
It does not look at your cloud account. It does not check if you have the right security permissions. All it does is check your local syntax. It checks your grammar.
Just the grammar.
Yeah. Did you forget a closing bracket? Did you reference a variable that you haven't declared? Did you misspell a resource type?
So Validate is strictly checking the blueprint itself for typos. If I write a blueprint that says, build a door on the ceiling, Validate will pass it because linguistically, the sentence is grammatically correct.
Yes.
It's a perfectly spelled request. It's not Validate's job to tell me that a door on the ceiling violates the physical laws of gravity.
That's a great way to put it.
Cool.
To take that a step further, Validate has no concept of cloud reality. If you request an AWS server type of like T2 super mega large,
Which does not exist.
which does not exist, Validate will say, look structurally correct to me. It isn't until you actually try to talk to AWS that you'll discover the cloud provider rejects that request. Knowing where Validate stops, which is local syntax, and where the cloud begins, is guaranteed to earn you points.
All right, so the blueprints have perfect grammar and standard spacing. But how do we know if the door on the ceiling is actually going to build? Here's where it gets really interesting. Phase 3, the architect's review. This is Terraform plan.
And this is arguably the most powerful concept in the entire workflow, really, because it relies on Terraform being a declarative state engine.
Wait, declarative state engine? Let's break that down for someone who has only ever written basic scripts before.
Sure. So in traditional imperative scripting, you write out the exact steps, right? Do this, then do this, then do that.
Yeah, very step by step.
Right. Terraform doesn't work like that.
Yeah.
With Terraform, you just declare the end result. You say, I want 3 web servers. Terraform's job is to figure out how to make that reality.
Okay.
To do that, it uses the state file we mentioned earlier. The state file is essentially a massive JSON document that maps your written code to the actual physical IDs of the resources running in the cloud.
So when I run Terraform plan, it's basically doing a math problem.
Exactly. It takes your written code, the desired state. It looks at the JSON state, the current reality, and it calculates the delta.
Wow.
Yeah, the output of the plan command tells you, if you approve this, here's the exact mathematical difference between what exists right now and what you were asking for.
And deciphering that output is like reading a secret code, but it's one you have to become incredibly fluent in. When you run it, it spits out a list of resources with specific symbols next to them, right? Like a green plus sign means it's creating something brand new.
Right.
A red minus sign means it's going to destroy something.
And then you have the yellow tilde, which indicates an update in place. This means Terraform is going to change a configuration on an existing resource without destroying it, like, I don't know, adding a new tag or updating a description.
That makes sense.
But you have to read carefully, because sometimes you'll see a minus and a plus sign together. That means force replacement.
Wait, force replacement, so it destroys it and rebuilds it simultaneously. Why wouldn't it just update it?
Because certain things physically cannot be hot swapped in the cloud. Like if you try to change the foundational operating system image of a running server, you can't just slide a new OS underneath running applications.
Yeah, that would break everything.
Exactly. The cloud provider's API simply won't allow it. So Terraform has to destroy the old server entirely and build a brand new one in its place.
That is terrifying. If you're not paying attention to the plan output, you might think you're just making a minor tweak, when in reality, you're about to vaporize a database server and build an empty one.
Yes, which is why reading the plan is so critical.
Okay, so we've run the plan, we've reviewed the symbols, and it looks safe. Now, the notes emphasize a specific flag here, the out flag. Like Terraform plan out my plan.tf plan. But I don't really get this. If I just saw the plan on my screen and it looks good, why do I need to save it to a separate file? That feels like an entirely unnecessary extra step.
It feels unnecessary until you experience your first race condition in a team environment.
A race condition.
Let's ELI5 a race condition for a moment. Imagine two architects are working on the same physical blueprint at the exact same time, but they aren't talking to each other.
Okay, recipe for disaster.
Exactly. So you run a plan on Friday afternoon. It looks good. You are going to add 3 new web servers. You leave it on your screen, go grab a coffee, and 30 minutes later you come back to apply it. But while you were getting coffee, your coworker merged a massive code change that alters the underlying firewall rules for the entire network.
Oh, wow. So the reality of the cloud just shifted under my feet while I was in the break room.
Yes.
If I just blindly hit apply based on the plan I read 30 minutes ago, I might deploy my servers into a network that no longer exists or just overwrite their work entirely.
Precisely the danger. By using the out flag, you are saving that exact specific mathematical delta to a file.
Oh, I see.
When you move to the next phase and run the apply command, you feed it that exact file. It guarantees with cryptographic certainty that exactly what you reviewed is exactly what gets built. If the state of the world changed while you were getting coffee, Terraform will refuse to apply the save plan and will throw an error.
That's amazing. It's protecting the entire system from a disaster. It's literally sealing the blueprint in a tamper-proof envelope. I love that.
It really is.
Okay, so we have this cryptographic tamper-proof plan saved on my hard drive. But it's still just a document. How do we actually pull the trigger? That takes us to phase 4, construction and demolition. We're bringing in the concrete mixers, or, well, the wrecking ball. This is Terraform apply and Terraform destroy.
Right. So Terraform apply is the command that actually makes the API calls to the cloud providers and builds your infrastructure.
Yeah.
Now, as we just discussed, you can run it by passing it that save tamper-proof file.
And it just goes.
It immediately executes. But if you just run Terraform, apply completely on its own, it will actually run a fresh plan first, show it to you on the screen, and pause. It will prompt you to manually type the word yes to confirm you actually want to proceed.
Ah, the famous human safety checkpoint. But there's a flag that skips this, right? The auto-approve flag. This sounds absolutely terrifying. It just bypasses the safety check entirely.
It skips the prompt, doesn't wait for a human, and just blasts the changes straight into the cloud. And you're right, it is incredibly dangerous for an individual engineer to use on their laptop.
I would never.
I mean, one typo in your code and auto-approve will happily delete your entire production network before you can blink.
So why does it even exist then?
Because it is absolutely essential for continuous integration and continuous deployment pipeline CI/CD.
Oh, like automation.
Exactly. When you integrate Terraform into an automation platform like GitHub Actions, there is no human sitting there at a keyboard waiting to type yes. The code has already been reviewed by humans in a pull request.
Right.
Once it's approved, a robot takes over to do the actual deployment in the background. In automated workflows, you rely on auto-approve because the human review already happened earlier in the process.
Dangerous for humans, necessary for robots. Got it. Now, what about the wrecking ball? Terraform destroy. This command basically looks at your state file and burns it all down, right?
That's the one.
But I saw a flag called detarget in the study materials. It says you can target a specific resource for destruction. But honestly, trying to use detarget in production feels like, I don't know, trying to swap out a foundational steel beam on the 10th floor of a skyscraper while the 11th floor is currently occupied.
That is a very accurate, very anxiety-inducing way to look at it. Terraform relies on a massive web of dependencies. The web server depends on the subnet, which depends on the virtual network, which depends on the routing tables.
It's all connected.
Yes, if you tried to surgically target just one resource for destruction, you run a massive risk of corrupting that entire dependency web. You leave your infrastructure in a fractured, really inconsistent state.
So I assume HashiCorp officially discourages its use.
Highly discourages. The exam wants you to know that a target exists mostly for exceptional emergency circumstances, like recovering from a very specific, weird API failure, but it is generally avoided in standard workflows. You should be applying or destroying the configuration as a whole system.
Okay, so the building is up, it's beautiful, everything is running smoothly, but then reality hits. Let's say it's 2:00 a.m. on a Saturday, there's a massive outage, and some senior engineer, let's call him Dave, panics.
Uh-oh.
Dave doesn't have time to write Terraform code. Dave logs directly into the AWS console, manually opens a firewall rule to fix the outage, and goes back to sleep.
Classic Dave. And he just created a massive headache for the team on Monday morning.
Because now we have state drift. The blueprint says the door is locked, but reality says Dave kicked it wide open. Dealing with this is phase 5, reality checks. And this is a massive focus on the 003 exam. How do we get our local state file back in sync with the real world?
Well, historically, there was a dedicated command for this called Terraform Refresh. Its entire job was to reach out to the cloud providers, read the actual current reality, and silently update your local state file to match.
Okay.
So it would see Dave's manual change and silently update the ledger to say the port is open.
Wait, silently. So it just blindsides the team with the new reality. It just automatically accepts that Dave's 2 a.m. panic move is the new official truth?
Exactly the problem. It modified your state file immediately and without asking for permission. If a cloud provider's API returned a weird error, or if someone maliciously changed your infrastructure, refresh would just blindly overwrite your source of truth.
That seems really bad.
It was deemed entirely too risky. Which brings us to a major modern exam twist. The Terraform refresh command is actually deprecated.
Oh. So if I see a question asking for the safest way to update state, refresh is a trap. What is the actual answer?
HashiCorp introduced a much safer alternative. It's Terraform apply refresh only.
So what does this all mean? How does that actually fix the Dave problem safely?
It treats the state update just like any other infrastructure change. When you run apply refresh only, Terraform goes out, detects Dave's manual change, and then stops.
It stops.
Yes, it presents a plan on the screen. It says,
Yeah.
hey, I noticed the real world doesn't match your state file. Here's exactly what drifted. Do you want me to update the ledger to reflect this new reality? And it waits for you to type yes.
Ah, so it puts the human back in the loop. It gives you a chance to review the damage before committing it to the permanent record.
Exactly.
If Dave accidentally opened a secure database to the entire public internet, you see that in the plan and you can say, no, absolutely not, do not accept that. Then you can go fix the actual infrastructure. That is brilliant.
It's all about maintaining absolute conscious control over your infrastructure's source of truth.
Wow. Let's take a step back and look at the skyline we just built. We have traveled through the entire core workflow today. We started by prepping the site and downloading our heavy machinery with Init. We checked our grammar and formatted our blueprints with validate and FMT.
The essentials.
Right. We had the architect rigorously calculate the delta with plan and saved it with the out flag to prevent race conditions. We pulled the trigger with apply or brought out the wrecking ball with destroy, learning to respect the sheer danger of auto-approve and target. And finally, we learned how to safely reconcile our code with Dave's rogue 2 a.m. reality using apply refresh only.
Mastering these 5 steps does so much more than just help you pass a certification exam. It transforms the way you think about systems.
Yeah.
It changes you from someone who just, clicks around in a web console hoping things work, into an engineer who can orchestrate massive global scale with absolute confidence.
It's the difference between building a sandcastle and building a skyscraper. One washes away with the tide, the other stands for a century.
This raises an important question, though, something really worth pondering. We use declarative tools like Terraform to enforce absolute order, right? To ensure our code is the undisputed truth of our infrastructure.
Right.
But if the ultimate goal is to perfectly align digital reality with our written code, what happens to a company's culture when the tool that builds everything becomes the single point of failure for the entire organization's workflow? As we move toward a future of complete automation, can we ever truly reach a point where we trust the code more than we trust our own eyes?
Oof. When the blueprint becomes more real than the building itself, that is a heavy, fascinating thought to leave on. Thank you so much for joining us on this deep dive today. Whether you are taking the exam tomorrow or just starting to figure out how to build your first server, remember that every massive tower starts with just a patch of dirt and that first init command. Keep building, keep questioning the blueprint, and we'll catch you on the next deep dive.